So now in recent videos, we've been using mostly mathematical formulas. We do quite a bit of multimeter work, but we're going to look at using the multimeter to measure voltage across components in more detail in this video. That's going to be its primary focus. So the power supply voltage, if you have a red LED and about 20 milliamps of current, the red LED is going to block about 2 volts. The rest of the voltage goes across the resistor where it sets the current. So I have this power supply set to 5 volts. We went over this a lot in the last videos. And there you can see it's about 20 milliamps of current. This isn't perfectly accurate, but it's usually correct to about 2 milliamps. So maybe 17, maybe 21. But I think it's probably 20 milliamps about exactly. 150 ohm resistor. So we can actually measure the voltage across any component at any time, and that's actually a good skill to get because that lets you know what the circuit is doing. So first let's measure the power supply rail, and it should be pretty close to spot on 5 volts. So again, it's not perfect. You don't get perfect numbers usually, but you get a very close estimate, which is good enough in electronics almost all the time. And now once I make a connection to both of the pins of the LED, it's kind of blinding me, but it's easier to see it on camera than in person. But there you can see it's pretty much spot on 2 volts. I'm actually surprised. That's closer to 2 volts than I thought it would be. But it is blocking 2 volts, and then the rest of the voltage goes across the resistor, which sets the current. So looks like it's a little more than 2.9, but we can just basically say 3. And so the resistor is actually what's setting the current. And we just saw we have about 20 milliamps right there. What we're going to do is grab the green LED. So green LEDs, this particular type, these indicator LEDs that have the through hole that go into the board. And there you can see the LED is quite a bit brighter. The camera actually might not pick it up as well as in person, but it is really bright. So we're going to see that it is blocking about 3 volts, and you could see the 3, but I'll move that there so we can see it a little bit better. So we got 3 volts across the LED, which means even though it's brighter, there's less voltage across the resistor. Right there I have the probes backwards, but now there's 2 volts across the resistor. So we should actually have about 2/3 of the current. And if we go to the power supply here, there you can see instead of about 0.019 amps, we got 0.011, so about 11 milliamps. Again, this is not as accurate as a multimeter, but it's not bad. So in any case, you can tell a lot with the circuit just by measuring voltages across the individual components. So now I took out the 150 ohm resistor and put a 390 ohm resistor. I turned the power off first, and what we're going to do is first I'll turn on the power, and you can see that at 5 volts we have less current, which makes sense because that's a higher value resistor. So now we're going to raise the power supply voltage to 10 volts, and this is why I have a pretty much 400 ohm resistor. It's 390 because I don't have a 400, because I did the calculation to see that's what I need for about 20 milliamps of current. And so the resistor gets a little warm at this point, but in case there you can see we got the 20 milliamps of current. We can take those same voltage readings, and so we'll just go across the LED right there, 2 volts, so it's still holding. That's because of the 20 milliamps of current going through it. And so lower currents, it will block a little less voltage, but it'll still be pretty close to blocking about 2 volts. And there you can see now we have 8 out of the 10 across the resistor, just slightly less. And of course the green, it's going to look a lot brighter, and they're extremely bright at 20 milliamps. So you don't have to go 20 milliamps. That's not the goal, to try to max out electrical components. You get them as bright as you need. You just look at that maximum as a warning not to go above it. So there we got 3 volts across it, even though it is massively brighter. I short-circuited the only to here though. Current still went through the resistor if I short circuit there, so the power supply didn't get voltage. Didn't get short circuited, so I got the pros backwards again. There you can see now we only got about 7 volts across the resistor, and of course with the green LED, since we're working with the higher voltages, the current drop is not as dramatic because we're not losing the green LED. When it came to 5 volts was taking most of the power supply voltage, whereas now it's only taken, I don't know, like a little less than a third or something. So the current drop's not going to be as bad. So higher voltages are a little more they have a little less problem with adding more components in series than lower voltages. So that's something you have to take into account when you're designing circuits. And finally, I turned the power off, swapped the resistors for a 680 ohm resistor. That is because doing the math, we saw that 650 will give us 20 milliamps at 15 volts minus the 2 volt of the dial drop, but the resistor is at its maximum wattage rating, so it's probably going to be about 0.25 since it's slightly higher than 650. So we don't want to do this terribly long, but short periods of time shouldn't really hurt it too bad. And if we put a fan on it, it might even actually be somewhat okay. So I'm going to hit the power button of the supply. LED is on, and so we need to up the power supply voltage now. That's why I made sure we did the resistor and everything first, and we will go up to 15 volts, and there you can see it's pretty much 20 milliamps, so 0.019. Again, we will just measure the voltage. We already went through this, but we'll do it really quick again. And still, even with the higher voltage, because we have the current set to 20 milliamps with the resistor, it's still 20 milliamps right there. And so there's that 13 volts, 15 minus 2. And now we are going, it does say 20 on there now. And so again, we're going to do the green LED, and so it's really bright, but again, it's still blocking 3. We already saw all that. And then the rest across the resistor. And the current, I think, is a little bit higher now because we're dealing with more voltage. It's I think it was 17 milliamps, now it's 18. Again, it'd be more accurate to measure with a multimeter. And that's good practice. That helps you understand what these electronic components are doing, because all you can really see is an LED lighting up or not lighting up without a meter. And so the meter really gives you the insight into what is going on electrically, and that's how you can troubleshoot and whatnot. You'll know the voltages that should be at a certain area or whatnot. If you don't find those voltages or voltages you don't expect, either you have to figure out what you were wrong in your thinking, or what is wrong with the circuit to get the voltage that you need. So, in any case, went a lot longer than I expected, and it's probably the last I'm going to do of these topics here. And so, if you're getting bored with them, I'll probably have something new in the next video in this series. So, thanks for watching. Click one of these other videos and watch them. I will see you in the next video.